Hi guys, this is going to be a quick video, hopefully a review, because I think you guys learned this when you were in geometry, but permutations and combinations. So the first one we're going to talk about is a permutation. So it says 8 people are running in a race. In how many different ways can they come in first, second, and third place? This is a problem of counting permutations or arrangements, and the results can be represented by 8 permute 3. So this 8p3, which means the number of ways to choose and arrange 3 different, not repeated things from a set of 8 in which order matters. So in permutations, order matters because someone has to come in first, second, third. And if you switch those orders, then that's going to be a different arrangement or permutation. There are several ways to compute 8 permute 3. So one of them is in your calculator. So if you go to your calculator, you can type the total number you have first, which is 8. You're going to go over to math, probability, and then you have NPR right here. So you can go down to P. So I have 8 things I'm choosing from, and I want to choose 3 people to get first, second, third place, and I want to figure out the total number of arrangements that would be possible. So if I click enter, that'd be 336 total different arrangements of how that could happen. Another way of doing this 8 permute 3, is the fraction of 8 factorial divided by 8 minus 3 factorial. So the n minus the r factorial here. So this becomes 8 factorial over 5 factorial. Factorial simply just means you are multiplying all the way numbers down all the way till you get to 1. So 8, 7, 6, 5, 4, 3, 2, 1, 5 all the way to 1. And so then here, these ones are actually going to cancel out. So if I can draw on here, then the 1, the 2, the 3, the 4, and the 5 all cancel. So we're only left with 8, 7, 6. So then it would just be 8 times 7 times 6, and we get the same 336 total arrangements that are possible. So here's your general formula for that. So NPR, you do the n factorial over n minus r factorial is n times n minus 1 times n minus 2 all the way down until you get to n minus r plus 1. So if this one were so that's just your formula for n items chosen at an R rate. So this is how you guys would set that up. Okay, the next one is a combination. These are lists of groups without regard to the order within the group are called combinations. In selecting committees, it matters who is selected, but not the order of selection or any arrangements of the groups. Selections such as those with committees are called combinations. Note that combinations do not include repeated elements, but that the order doesn't matter. So for example, 8 people are eligible to receive $500 scholarships, but only 3 will be selected. How many different ways are there to select a group of 3? So it doesn't matter who's chosen first, second, third, but it does matter who of the 3 are chosen. So that's how this is a combination. This is a problem of counting combinations. Instead of using the P, you do C. So 8 choose 3 represents the number of ways to choose 3 from a set of 8. This is sometimes read as 8 choose 3. So 8 choose 3. To compute the number of combinations, first calculate the number of permutations and then divide by the number of ways to arrange each permutation. So 8 choose 3 is going to be 8 permute 3, so what we did above, divided by 3 factorial, which really ends up becoming 8 factorial over 5 factorial, 3 factorial. And then we have, this becomes 56. So if we do this in our calculator, oh, and I totally messed this up. This formula right here. So ignore that. This should be also 8 minus 3 factorial. Times 3 factorial. So that's how you get this 5 factorial here. Okay, so in general, the number of ways should be the number of ways to choose and arrange. So your permutation, n permute, NPR, divided by the number of ways to arrange, which is going to be r factorial. And then that becomes n over n minus r factorial. Oh, maybe not. Maybe I did that right. I think this is probably fine. Okay, and then you can also use your calculators. So then you would just do, again, 8 math probability, and then instead of choosing the P, you would choose 3, and then you click enter. So there's going to be 56 total ways of arranging those 3. Okay, so I'm going to do 2 example problems with you, and then your guys' homework is just going to do like 6 more of these where you just have to practice. So the first example, it says there are 25 students. 4 of these students are selected to attend 4 different conferences. The first student selected will go to a conference in Maitiki City. The second will go to Paranaque City. The third to Quezon City, and the fourth to Caloocan City. I bet you guys enjoyed the way I just said that. How many selections are possible? Okay, so the first thing you have to consider in this one is, does order matter or does it not matter? And in this one, it does matter because whoever is chosen first goes to a different city than someone who is chosen second. So order matters. So if order matters in this one, that means it's going to be a permutation. Order matters. Okay, so we do the total number of people we have to choose from. So we have 25 to choose from. We're doing a permutation because the order matters. And then we are trying to choose different groups of 4. And we want to figure out what that looks like. So I'm going to go to my calculator and I'm going to type 25. We're doing a permutation, so probability, permutation, and I'm choosing 4. So the answer to this one would be 303,600. So the answer to this should be C. Okay, last one. A college has 13 instructors qualified to teach a special computer laboratory course, which requires 2 instructors to be present. How many different pairs of instructors could there be? So in this one, order doesn't matter. You're just choosing 2, and it doesn't matter who's chosen first or second. So this one's going to be a combination. So you have 13 total instructors, and you are trying to choose 2 of them. So 13 choose 2. If we go to our calculator, oops. And I even chose the wrong one. Okay, let's try that again. 13, choose. And I was trying to choose 2 professors. So then that's going to be 78. So then your correct answer for this one would be A. Okay, so I hope that makes sense. And neither one of these are repetitions are happening, but you're choosing whether order matters or doesn't matter. You guys are just going to go do a couple more problems of this, and then you're going to upload it to Google Classroom. As always, I hope you guys are having a great day. You are almost to the end of summer, so keep hanging in there, and I will talk to you guys later. Bye, guys. Miss ya.